Hi everyone, welcome back to the channel. Hope you guys are doing great and welcome to the lecture series, Let's Learn Quantum Computing from Scratch. And today we are back with another video, and this time we will be talking about the binary arithmetic operations. But before we get into this, let's have a brief recap of what we did in the last video. So in the last video, we talked about what number systems are. We looked at a few examples of the number systems. For example, you have decimal number systems, which are also known as base 10 number systems. You've got binary numbers, number system that's base 2. You could have base 3, base 4, base 5, base 6 number systems, and so on. You could have like as many number systems as you could think of. And the ones that we were most interested in were the decimal number system and the binary number system. The reason why we were interested in the decimal number system is because it is the number system that we're most familiar with. It is the one that we actually used to learn how to count objects. We learned how to perform arithmetic operations, addition, subtraction, multiplication, and division. So this is the one that we use in our daily life. So that's why it's important to know what this number system is really about. And the binary number system, because since we're learning about computing, and we know that computers are electronic devices that operate on zeros and ones. So our computers basically do not understand the language that you and I communicate with. So a computer has its own language, and that's the language of zeros and ones, which are also known as the binary digits that belong to the binary number system. And with the help of these zeros and ones, with a combination of these zeros and ones, you construct various, like infinite many binary numbers that belong to the binary number system. So therefore it's important to know what binary number system is. And by the end of that video, we looked at how we could convert from one number system to another number system. So given a number in, let's say, a number that belongs to the decimal number system, you could convert it into its relevant binary form and vice versa. So we saw that in detail. So if you haven't watched that video yet, you can click on the link that will appear at the top right corner of this video, and you can go there and you can watch that entire video if you haven't watched it already. But let's begin with today. So quickly, there are 4 arithmetic operations, and we all know those, right? We have addition, subtraction, multiplication, division. But what we've done is that we're actually going to divide this video into 4 parts. So this is going to be the first part, where we will be discussing addition only, because we can't cover all of these operations in just one video. It's going to take a lot of time. So we just instead divided into 4 short parts. So in this video, we will only be talking about addition. So without wasting your further time, let's get into it. So here are the 3 terms that appear on your screen: augend, addend, and sum. These 3 terms are associated with addition, and augend is actually the term that is used to describe quantity to which you want to add another quantity, right? And addend, as the name suggests, it's going to be the quantity or that number that is to be added to augend. And so here you've got 2 numbers, 5 and 2. So you want to add 2 to 5. So your 2 is going to be the addend, and your 5 is going to be augend. And the result of addition is known as the sum, right? So this is some very basic stuff that we're all familiar with. But today what we want to do is that we want to learn, how do we add binary numbers? So there are 2 approaches that we're going to look at. The first approach is that you've got, for instance, you want to add like 2 binary numbers. So what you do is that you convert each of them into their relevant decimal form, and then you add those decimal numbers together, you get the result, and then you convert the decimal number back to the binary form. So this is the first approach. The second one is that you don't convert, and you've got those binary numbers and you just directly add them. So that's a more direct and short approach. Before we proceed, let's look into some of the rules of binary addition. So if you look at the first block, it says 0 plus 0 is always equal to 0. This is nothing new. This is what we've also learned, in our elementary math classes as well, when we used to deal with the decimal number system only, that 0 actually means nothing. So nothing plus nothing equals to nothing, right? So 0 plus 0 would always give you 0. So this is nothing new. Then if you look at the second block, again, this is also nothing new to us. We already know this, that 0 plus 1 equals to 1. Any number when added to 0 gives you back that number. So you could actually say that 0 is additive identity. So these two blocks, they're not new to us. We already know this. So there's nothing interesting here. However, when you look at this third block over here, it says that 1 plus 1 equals to 1, 0. This is where things get a bit tricky, because when we used to learn addition in our elementary math classes, where we used to deal with the decimal number system, whenever we had 1 plus 1, it always equaled to 2. But now in the binary number systems, it's not equal to 2, as it's equal to 1, 0. And the reason is quite simple, actually, because there is no digit 2 in the binary number system. The only digits that you have in the binary number system are just zeros and 1, or 0 and 1. And the numbers, the infinite binary numbers that you construct out of this number system, is just the combination of those zeros and 1s. 0 is the first digit of the binary number, and the second digit and the last digit of the binary number is 1. So therefore, you cannot have the digit, the number 2 in binary number system. Therefore, 1 plus 1 cannot be equal to 2. So how is 1 plus 1 equal to 1, 0? This is what we are now going to see, right? So if you look at this table right over here, you see that the first column of this table shows you, the first few decimal numbers from 0 to 6. And the second column actually shows you the relevant binary form. So, and if you just take a closer look at this, at the first two, these two rows here, you would see that the 0 that belongs to the decimal number system is actually equal to the 0 that belongs to the binary number system. And the 1 that belongs to the decimal number system is actually equal to the 1 in the binary number system. So here these 0 and these 1s are equal, right? So, but when you have 2, so there is a slightly different version of it in the binary number. 2 is not equal to 2, it's equal to 1, 0. Now, one thing to note is that like we discussed, we know that in decimal number system, you've got digits from 0 to 9, and all these digits are arranged in a particular order, and that order is fixed, and therefore all the numbers that you build in the decimal number system, they also appear in this particular order that is also fixed, right? So in the same way, the digits that appear in the binary number system, 0 and 1, their order is also fixed. The first one, and the numbers, the binary numbers that belong, they also have a particular order, and this order is also fixed. Like 0 will always be the first binary number, then comes 1, then comes 1, 0, then comes 1, 1. Then 1, 0, 0, 1, 0, 1, and 1, 1, 0, and so on. But let's just look at that. How are we constructing these binary numbers, right? And that's actually very simple. What you're actually doing is that you're actually using the combination of zeros and ones in a very in a particular arrangement, in a particular sequence. This is happening. So what you do is, for instance, if you pick this 0 first, so you would first make the combination of 0 with 0 and 1, right? So 0 comes before 1, therefore the first combination is going to be with 0 and then with 1. And you see that this gives you 0, 0, and 0, 1. Now, and that is just equal to 0 and 1. Now, what does this actually mean? No matter how many zeros you put before the zero, like 0, 0, 0, 0, 0, it's just equal to 0, right? And no matter how many zeros you put before this digit 1 here, it's just going to be equal to 1. Now, what this 0 is actually telling you is that there is no, for instance, if you just go back and try to look at the decimal number system, let's just look at the number 2. It's a unit digit number, right? It only has the place value of 1. It's a single digit number, and all the single digit numbers have place values of 1. We know that they do not have any place value of 10, hundreds, or thousands, or 10,000s, or 100,000s, or 1,000,000s. There are no positions, there are no digits in those place values or in those positions. So you put zeros over there. That 0 means that there's nothing. So it doesn't really matter whether you put a 0 before the single digit or if you don't, it's just the same thing, right? So the first two numbers of the binary number systems are just 0 and 1. Now, once you reach this one here, that is the end, that's the last digit of the binary number system. So this means that now your single digit numbers come to an end, and now you have to shift to, two-digit numbers, right? And those two-digit numbers will actually be formed by combining taking 1 and taking its combinations with zeros and ones, right? So you would then have 1, 0, 0 comes before 1, so you would then have 1, 0, and then you would have 1, 1, right? Now you've reached 1, 1 here, so that means that that's the end of, the two-digit numbers. So this means that you now shift to creating three-digit numbers. So what would you get? You would get a 0 here, a 0 here, and a 1. So now the first number of those three-digit numbers is going to be 1, 0, 0, and then you would have 1, 0, 1. So I hope you understand the sequence, the pattern in which you are constructing these binary numbers. It's just a way of putting or arranging these numbers together, and that creates the order over here. So if you just go a little bit back here on this table, you can see this, right? So you've got two single-digit numbers. After 1, you shift to two-digit numbers. And now the thing is that the single-digit numbers, like I told you, it's just 0 and 1. So I could write this 1, 0 as 0, 0, 0, 0, 0, 1, 0. It would be the same thing because any zeros before this 1, 0 do not have that much of a significance. They just tell you that there is no digit or no number, in those place values. So you have 1 first, and then you've got like this 0. Then you have 1, 1, right? And then when you have this 1, 1, so that means that's the end because 1 is the last digit of binary number. So that's the end of the two-digit number, and then you shift to three-digit numbers and so on. So when we said that 1 plus 1 equals to 1, 0, what does that mean? You have the first digit 0. When you want to move to the next number, you have the first number 0, and you want to move to the next number in the binary number system that gives you 1. Then here what this is telling you that you have now reached 1 and you want to move to the next binary number. So that's going to be 1, 0, right? And then if you want to move to the next binary number, you add 1 and you move a step forward. So you could, like, for instance, think of it as stairs. The first step corresponds to 0, then 1, then you have 1, 0, a step. The third step, the fourth step would be 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, and so on. So this is the order in which. So that's why 1 plus 1 gives you a 1, 0. And if you had like 1 plus 1 plus 1, that's going to give you 11, right? And so on. Now here we have two examples. So let's just practice these two examples. And we will first solve it with, now there were two approaches that I just told you to, add binary numbers. And the first approach is, we'll now look at the first method, that's converting from binary to decimal. And let's look at the first example. So you've got 3 ones and you want to add them together. And so what we do is that we convert the given binary numbers to their relevant decimal form. And we already know that the 1 in the binary number is just equivalent to the 1 in the decimal number, right? So they're just equal. So you could treat it as a decimal number, 1 that belongs to the decimal number. So 1 plus 1 equals to 3. And then you got this result 3. What you do now is that you convert the result 3 back to its binary form. And the way to do is that you divide this number 3 by 2. Right, why 2? Because we're talking about binary numbers, which are base 2 numbers. Therefore, you have to divide this number by 2 in order to convert it to binary number. And so 3 divided by 2 gives you 1 and remainder 1. Right, so the remainder of this division is 1. And then you pick this 1, you divide that by 2, that's equal to 0, and you get the remainder of this division as 1, right? Basically, 3 divided by 2 is exactly equal to 1.5. We know that, but we are not considering that 0.5. You're just considering the whole number, and you're looking at the remainders, right? And 1 divided by 2 is actually equal to 0.5, but you're not considering 0.5. You're just going to consider 0, the whole number, and the remainder 1. So you're actually looking at the quotients of this division. We've actually discussed this method of converting from decimal to binary, right, in our previous video. So if you haven't watched that yet, you can go and watch that. So you keep on dividing this number until you get a 0 over here. And once you get 0, you stop and you look at your remainders. And the way to look them is that you look at from bottom to top. So you get 1, 1 as the result. Let's look at the second example now. So again, you've got these two numbers, 101 and 111. So what you do is that you convert them to the relevant decimal form. And the way to do is you've got this number 101, right? Now, this is a 3-digit binary number, and each digit of this binary number has its own value that we call as the place value. And we've learned about place values in our elementary math classes. The concept is very much similar in the binary numbers as well. The only difference is that we were dealing with, the base 10 in the decimal number system. Now you just have base 2. So now these positions over here of all these digits, they correspond to powers of 2 instead of powers of 10, right? Because now you're dealing with base 2 numbers. So the rightmost digit is the least significant digit. That means that it has got the least power of 2. That's 2 to the power 0. And then if you move to 0, its power becomes a little bit higher. So now it's 2 to the power 1. Its position is 2 to the power 1. So it's now more significant than this purple one. And then when you move to this leftmost digit here, so that's the most significant digit because it has 2 to the power 3. So the power of 2 is greater here. So then you could expand, this, or you could actually write this down as 1 times this purple one as 1 times 2 to the power 0, 0 as 0 times 2 to the power 1, and this 1 times 2 to the power 2. So this is how you would be converting this 101 to its decimal form. And then when you add them up together, you get 5. And then you apply the exact same procedure to this 111 and you get the result 7. Now you've got your decimal numbers, you add them up. So 5 plus 7 equals to 12. Now you got the result, you convert the result to the binary form by dividing this 12, divide this 12 by 2, and you keep on dividing until you get 0 here. Once you get 0, you stop and you look at the remainders from bottom to top, and the result that you get is 1, 1, 0, and 0. So that's the result. So this first approach is, it's what do you call that? It's a bit longer way of, it's time taking, right? It's a long method of, adding binary numbers. It takes a lot of time. And if you want to be quick and short, so then you just add them directly. So let's look at the second method, that's the direct approach, where you don't have to convert, you just are given the binary numbers and you just add them up directly. So let's look at the first example here. Following these adding binary number rules, right? And now we know that how 1 plus 1 equals to 1, 0. So we're going to apply that same, approach to this first example. So how do you do this? So the way to do this is that you first add these two numbers, the first two numbers here. So we know that 1 plus 1 equals to 1, 0, because after 1 comes the number 1, 0, right? So 1 plus 1 equals to 1, 0. So you can't write 1, 0 like this. So what do you do in addition? So you keep the 0 here in this column, and you carry the 1 to the next column. It's the exact same thing that you've done with, in the decimal number system. The exact same method. Nothing has changed, right, in the regular rules of addition. So you keep the 0 in this column and you carry the 1 to the next column, which is this column of more significant numbers. And then you have this 0, so you now add the 0 to 1, you will get a 1, and you bring this 1 down because 1 plus 0 equals to 1. And you get the result 11 like this, right? So you could simply write this down as that you added these two numbers together, you got a 1, 0, and then you just have this 1, 0 like this, and you add this 1, 0 to 1, and you get 1, 1. So now let's look at the second one. So now in the second one, you have like 1 plus 1. So what's that going to equal to? 1, 0, we know that. So you keep the 0 in this column and you shift the 1 to this one, to this column right here. So now you have 3 digits, 1 plus 0 plus 1. So you add them together. 1 plus 0 equals to 1. 1 plus 1, again, we know it's equal to 1, 0. So you keep the 0 here and you carry the 1 to the next column. Now you have 1 plus 1 plus 1. So you know that 1 plus 1 equals to 0. You keep the 0 in this column and you shift the 1 to the next column, right? And then 0 plus 1 equals to 1, right? So you get a 1 here and you carried that 1 of, this addition to this column. And now here the addition is going to proceed as 1 plus 0 and you get a 1. And that's it. So this is it for today. That's all what we wanted to discuss. And in the next video, we are going to look at what subtraction is. How do we subtract binary numbers? And yeah, so that was it for today. Take great care of yourself and we'll see you soon. Bye.